Are we out there? I think we're live. Hello, hello. Hello, hello. All right, so let's test the board. Um, So first, let's see who's out there. Hi, Leanna. So I just want to make sure that the board is working. Uh, Hello, hello. Good morning, Sarah, Gianni, and Leanna again. Let's see. The links are up. I have to find a good word. I think we already spoke about this. It is Tuesday. I have to make it more interesting. Let's let's see. Ah, I have it. So please test the board. Let's make sure that it's working. Yes. Yes. I've been having waffles every morning. They're so good. Oh my gosh. Waffles are better than pancakes. Yeah, you know what? Here's the thing with pancakes. It's kind of hit or miss. I've been to, well, my recommendation, I would never go to a diner and order pancakes. I feel that they get the outer part of the pancake, or it cooks well, but then the middle is just raw and it's terrible. But IHOP does a pretty good job. I think, their success rate is at least over 90% every single time. Waffles, that's right. We can talk about food all day, right? I was going to mention Taco Tuesday, but we already did that. So I hope everyone's doing well. I saw some submissions over the night, some past midnight. I'm not judging here. I'm just glad that everyone was able to, submit it. I'll look at all the details a little bit later. It's been a crazy busy week for me. I'm sure everyone over there is crazy too, on the other side of the screen, or my screen. I hope you enjoyed my picture. It's a scene from the show, my favorite show right now, Money Heist. I love the show so much that I bought a Funko Pop. I bought the professor, that's the main character, and he has a Funko Pop. I feel like everyone has a Funko Pop. You could make your own Funko Pop, FYI, if you really had, a lot of free time and a couple of, I don't know how much it costs, but you could make one. So maybe that could be a gift idea. If you're ever wondering, like, oh, what could I give my significant other or a friend or what have you? Make them or make a Funko Pop out of them. Why not? Anyway, all right. So I don't want to take up too much time today. I believe the homework was pretty simple. I don't want to spend too much time going over it unless you really need clarification. It should have been straightforward. It was again applying the change of base theorem to some examples. So if you don't have any questions, then we'll move along. And going back to, let's see, they realize waffles. Yeah, I know waffles are good. Waffles. I was just going to comment that I'm not making fresh waffles. They're frozen. Don't judge me, but you know, at least I have something to eat. All right. Do I have coffee in hand? I'm running out of coffee, so I have to make more. Let's see. So today, what we're going to do, we're going to try to solve logarithmic equations. So some properties of logarithms. So if we have the following scenario, we have if x equals to y, then we should be able to say that log base a of x will equal to log base a of y. I think that's pretty, obvious. It should be. It would be the equivalent of saying, if 5 equals 5 as an example, right, then log base, I don't know, a of 5, whatever a is, should equal to log base a of 5, right? Because if x equals y, that's essentially the rule. But now here's the issue. So if we look at this example, so hopefully you have the handout out. We have 7 raised to the power of x equals to 12. So we could try changing the base so that both bases here are the same. The only issue is that 7 is already in a prime form. And 12, I don't believe that we could rewrite 12. I mean, you tell me. Can we rewrite 12 as a single base raised to a particular power? So what power or what base raised to a power will give us 12? Is that possible? Right, because you can raise 2 to the x power, then you have 2 squared, not going to work. 2 cubed won't work, 2 to the 4th won't work. So we run into a problem. So what we're going to do is we're going to use logarithms to solve this. So if we looked at the previous example, right, where 5 equal to 5, and if you have a calculator handy, you could do the following. You could evaluate log of 5, and if we just throw in log in front of 5, the equation will be balanced. So what we're going to do to solve this, because again, we cannot rewrite 7 as a different base raised to a power, it's already prime. 12, although not prime, again, there's not a single base when raised to a power that will give you 12. So what we need to do is we need to manipulate it by the inclusion of log. So what's interesting here is that you don't need to pick a specific logarithm. It could be whatever base. You could have log base 30 if you wanted to. Log base 20. It's really arbitrary. It's random, but we should be, or we must be, consistent. So for our discussion, we'll do log. Actually, let's do natural log. I'm going to choose the natural log, or log base e, just because the example that I'm going to show you in a second displays that, so it's a little less confusing on your end. So, in other words, log base, or excuse me, natural log. Come on. So if we do the following, we're going to say the natural log of 7 to the x power will equal to the natural log of 12. So now what we need to do is we need to manipulate or solve this equation, because this we can do. So first things, we have this x here. And if we bring this to the front, again, using the power property, we're going to rewrite this as x times the natural log of 7 equals to the natural log of 12. So now we're in a position where, since this is multiplication, sorry about that multiplication symbol, it's terrible. Let's see. We need to solve for x. So we can apply the rules of simplification here, or isolating a variable, and we're going to divide the natural log of 7 to both sides. So in doing that, you need your calculator. You'll be able to solve for x. So I want you to take a moment to solve for x. I'll give you about 1 minute. And while you do that, I need to refill my coffee cup. So I just left the office, and I'm now in the pantry area of my virtual classroom, if you will. Probably sounds echoed, like a mile away, maybe. I assure you that the coffee is fresh. Maybe you hear it in the background. I'll let you enjoy, or is it I forget what it is, ASMR, is that what it's called? So if you hear that, coffee is being made. The soothing sounds of the environment. I think that's what ASMR is. That was not so soothing. That's an email notification. All right, so again, you're solving natural log of 12 divided by the natural log of 7. So if you do that, again, 4 decimal places. Let's look at 4 decimal places. And x should be approximately, did anyone chime in with x? Someone tell me what the value of x is. What is the value of x? Someone out there. Any value. Oh, it says here it's around to the nearest thousand, excuse me. So I need a value for x. Again, natural log of 12 divided by the natural log of 7. Where is natural log on the calculator? Very good question. So it all depends on what calculator you're using. Are you using a TI-84? Thank you, Brittany. I agree with you. But what calculator, Leanna? Which one are you using? It's under log, Leanna. Thank you, Brittany. So again, it would be under log if we are, I believe, using a TI. Do you have that, Leanna? Are you using your iPhone, Android, just a regular scientific calculator? So again, in using the again the approaches with the natural log, setting a log, the same log with the base being identical to both sides, then we find that x is approximately 1.277. No, Leanna, you're not blind. It's just, maybe the font is small. It's okay. Now you'll always know where that is. All right, moving along. So something to think about, and this you may do this by mistake, so we should avoid this. So when evaluating a quotient like natural log of 12 divided by the natural log of 7, do not confuse this quotient with the natural log of 12 divided by 7. So you can't just divide 12 and 7 and then take the natural log. It's not going to work. They're not equivalent. They're not equivalent. It's very different. So the natural log of 12 divided by the natural log of 7 does not equal to the natural log of 12 divided by 7. So this is very important. This you should star. You want to take a screenshot. Note whatever or however it is that you're maintaining our discussions. Very important point. So now we're going to get a little more complicated. So we have the following. Let's do here, we have the natural log, we have 3 raised to the power of 2x minus 1 equals 0.4 times x plus 2. So now, clearly more complicated. Now we have variables on both sides. We have this base that's an integer. We have a non-integer base here, 0.4. And clearly we cannot rewrite this, so we have identical bases. So we're forced here to use log. Again, you can use whichever logarithmic base you'd like to use. The go-tos are log base 10, because that's on your calculator, and also natural log. So let's practice natural log. So this way we get really comfortable with where it is. And let's see what happens here. So natural log of both sides, right? So natural log on the left, natural log on the right. So natural log of 3 raised to the power of 2x minus 1 equals the natural log of 0.4. And here we have this raised to x plus 2 power. Okay, so we need to do the following. We're going to apply the power rule to both. So I'm just isolating here or highlighting the power rule. So I'm going to rewrite this so we have now that power written in front of this natural log. And that's going to equal to x plus 2 times the natural log of 0.4. I'm just curious. I'm curious. Have um, have any of you ever tried to communicate with me on the board? Because there is a chat feature there. Have any of you done that? And I've just never noticed. So now here's where it gets a little bit complicated. Not too complicated, but we're going to have to apply the rules of distribution. So this is now where it's going to appear challenging, but you have to be very careful and organized. So in other words, if we look here, I'm going to take this, I'm going to block this, I'm going to block this, and we're going to multiply this into our binomial. I think once I did it first. Oh, thank you, Josh. Yeah, I'm sorry, I don't really notice it. I mean, I could try it. I don't know if you see that. But anyway, moving along here, we're going to distribute, so we have the following. So we're going to have 2 times the natural log. So I'm going to give the natural log a different color here. 2 times the natural log of 3 minus, and here we're going to have, again, because it's 1 times, we're going to have the natural log of 3 rewritten again. And then over here, so yeah, I'm just doing this slow just so we can have different colors. So here we have the natural log of, so here we have, hold on, here we have x times the natural log of 4, or 0.4, and this will be plus 2 times the natural log of 0.4. Okay. Oops. Sorry. I'm running out of room. Actually, no. I'm going to zoom out. Okay, natural log 0.4. So if you're at 100% magnification, I hope uh, it's obvious what I'm saying, but maybe not. So if you zoom out, you'll be able to see more of the screen. So anyway, let's see. So we have a problem here. We have all these x's. We have natural log here, natural log there, and it looks like a disaster. The goal is to solve for x. So that's the goal. The question is, how do we do that? So if we look here, we'll have the following. So we need to isolate x. That's number one. So I'm going to circle where x is right now. So x is here, or I'll box where x is. So these are our variables, and I'm going to circle our constants. So our constants are here. So I have to link the constants and the variables. That's the goal. So if I do that, I'm going to bring x times the natural log of 0.4 to the left-hand side. So watch. So I'm going to bring this over. It's coming over here. And then I'm also going to bring the natural log of 3. So I'm bringing this, oops. So this I'm just writing down here. Plus the natural log of 3 plus the natural log of 3. So in rewriting, we'll have the following. So we will have 2x times the natural log of 3, right, minus x times the natural log of 0.4. All of that will equal to 2 times the natural log of 0.4. I zoomed out again. Plus natural log of 3. So now you have the constants on the right-hand side and the variables on the left-hand side. I'll pause here right now to answer any questions that you may have. So if you have any questions, feel free to ask. Are there any questions right now? Okay, going once, going twice. So that's good. If there are no questions, then we are on the right path here. Great. So let's continue. Did anything come up? Nope. All right, good. Okay, moving along. So here's the issue. We have to get x by itself. So x is here and x is here. We're going to factor out the x. So factoring out the x, look at what we're left with here. We're left with 2 natural log of 3 minus natural log of 0.4. And all of this will equal to 2 natural log of 0.4 plus the natural log of 3. So when we divide this, now this needs to be divided. Hold on. I sent a question on the board. Let's see. Oh, some questions here. Why does this question have parentheses while the others didn't? So the reason why I put parentheses is because the exponent. So again, I'm going back to the board for a second. Going back to the board. So I scrolled up from the beginning where it was 3 raised to the power of 2x minus 1. 2x minus 1, think of that as, yes, there are two terms, but they're attached. It's one value, one quantity. So 2x minus 1 is the entire exponent. So I'm forcing it to act as one single quantity through parentheses. Because if we don't have the parentheses there, then you may forget to distribute. So you have to treat it as a single entity, and how you do that is by putting it in parentheses. So I hope that was a easy or a better way to understand why I had to do that. Right, moving along, and thank you for the question. So if we divide now, so we have to get x by itself, we're going to divide this whole expression. So now this is where it's going to be a pain in the butt. If you have a TI-84, you must be careful. If you have a TI-84, you can do it all in one shot, but I recommend doing this. If you're going to play with the TI-84, you don't want to, evaluate the numerator and the denominator individually. You can put all of this in parentheses, all of that in parentheses, and then you're going to divide it by everything that's here, but you must place this in parentheses as well. So 2 natural log of 3 minus natural log of 0.4. That we're going to divide to both sides. So I'm putting this in parentheses because if you have a TI-84, you're going to need to do that. Otherwise, you're going to get an incorrect answer. Because your calculator is going to say one thing, it's going to follow the order of operations, but you have to tell it to follow the order that you want it to follow. And the order is divide this entire numerator by this entire denominator. So this is gone now. And we're going to have a value for x. So I want you to solve for this. I'll wait. I'll give you about a minute. And we're rounding to, let's see, to the nearest thousand. So I'll change the screen so that you can see where we should be or where we went. So here, the way that they're doing it is it's proper. So the solutions or the example that I'm projecting right now or displaying, it's really trying to manipulate the expression so that it goes back to a single logarithm. So that's what's trying to occur right now, or at least a slightly less confusing logarithm. But if you do everything in one shot, we'll have the same answer. So if you see here in front of you where something is raised to the power of 2, I wouldn't worry about that too much. It's just the application of the power property, but kind of in reverse. But if you did this correctly, we have a value of x yet. Anyone out there? Waiting for a value of x. What is the value of x? Mac and cheese. So as you find x, I'm going to read your favorite dishes, your cuisine. Nice. Lasagna. Buffalo chicken pizza. That's pretty good, actually. I like barbecue chicken pizza. Oh my God. Let's see. Colombian, always. Pernil. Who doesn't like pernil? Oh my God, that's some good stuff. So if you don't know what pernil is, I will look that up. I will pronounce it in the American way so you can easily look it up. Pernil. 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 Baked chicken. Ooh, that's some good stuff too. Ceviche. Ah, it's excellent. So if you don't know what ceviche is, I would look that up. Wow, my favorite cuisine is Bengali. My favorite dish is biryani. I've had some pretty good biryani. Chicken biryani. The best uh, biryani that I've had, excuse me, it was in the UK. The UK. It was incredible. Incredible food. Ethiopian. Wow. That's awesome. I don't think I've ever heard anyone saying that they like that style of food. That's awesome. Very cool. Unique. I'm curious to know what a typical dish is from Ethiopia. I can't decide on one food. I know it's really tough. Anyway, let's go back. Let's see. So I have negative 0.236. I would agree. So that looks like a good answer. So if you look here, x will be about negative 0.236, approximate, right? Because you're rounding to the nearest thousand. So this is good. So this is an example of probably the more complicated type of logarithmic equations where you have to put variables on one side. You're going to have to factor and do all this manipulation in order to get x. So I think this is probably the most complicated example that we'll go over. But let's see. We'll continue. Yeah. Okay. So if we look at the next example, we'll be working here with A, example 3. So good work. Oh, let's see here. I got 0.912851. So I would double check the work. It might be a calculator issue, but if you're able to get the numerator that we have and the denominator that we have, then you'll be able to divide perfectly. So again, it's really about the parentheses at this point because you could have the correct work, but if the calculator doesn't know what you're trying to say, then it's going to give you that answer. So I would just double check because it seems at this point it's just an input error rather than a user or comprehension error, excuse me. All right, so let's look at this example. We have e raised to the power of x squared. So e raised to the power of x squared, this equals to 200. Again, remember, e is about 2.17. Oh, sorry, 2.71. And to change 200 into some base where it's raised to a power to get exactly 200 is not going to happen. So e, similarly, irrational number. So we're forced to use logarithms here. We might as well use natural log. Again, natural log is very user-friendly. And in this case, it's going to work to our advantage. Because here we have the natural log of e raised to the power of x squared. And that will equal to the natural log of 200. So what I'm going to do here is I'm going to let you solve this now. Because you have all the background that you need. So I'm going to give you a minute to solve this question. So natural log of e raised to the power of x squared is equal to the natural log of 200. So take a moment to solve that. So again, I'm giving you some time to solve this. So again, you have the natural log of e raised to the power of x squared. Don't forget that you have to apply the power property. Again, I'll just highlight what you need to be looking at. I want to give you the time to try this. So as you do this, I'm going to solve it on the whiteboard. I don't really want to say what I'm doing because some of you may be trying this or almost getting there. So if you're somewhat stuck, you'll see it play out in front of you. So again, if you still need a little assistance, look at the whiteboard. I'm going to do it. I'm not going to really describe the step by step because I just want you to see how this is done. And we've already described the step by step before. So I don't want to give too much away. But I will definitely go over it in a second. So again, something here. When you have the natural log of e, that's the same thing as saying log base e of e. And if we have the base matching with the output or the final answer of an exponential function, right, or an exponential equation or expression, excuse me. If that's the case, if they both match, then it's going to be equal to 1. Because the rationale is what power of e will give you e, and that's 1. So the only trick here, not so much a trick, but more so the evaluation of natural log of e. It's just equal to 1. So if we do that, we'll have the following. So x is going to equal to plus or minus 2.302. So there are more examples here. I want to jump to, let's see. I want to jump to an example like 4b. So I want to jump to an example like 4b quickly. I'm going to set you up here because now, before we were using logarithms to solve equations, but now we're going to go from logarithmic form to exponential form in order to solve. And I just gave you the solution. I did not mean to do that, but it's okay. So log base 2 of x cubed minus 19. This is going to equal to the following, 3. But remember, logarithms, to convert, when you read it, yes, you say log base 2 of x cubed minus 19. However, if the logarithmic, that notation, if it's too confusing, look at the log and say, what power? Log means what power? Think of it that way. Log, what power? So, what power of 2 is going to give you x cubed minus 19? And the power is going to be 3. So in other words, if you rewrite this, what power of 2 gives you x cubed minus 19? That will be 3. So 2 cubed will equal to x cubed minus 19. So when you solve this, it actually becomes a very simple question. So again, log base 2 of x cubed minus 19 equals to 3. Another way of saying that is what power of 2 gives you x cubed minus 19? That power in this example is 3. 2 cubed gives you 8. Isolating x cubed will be 27, or will equal to 27, but taking the cubic root of that is just 3. So I hope that this was somewhat clear today, because we've run out of time. So just a few things. I hope that everyone submitted their work, the project that is. So what I did was I gave an extension on the homework that should have been due today. I'm letting it due or be due later today. Or sorry, yes. So the homework that was supposed to be due yesterday. Sorry, I forget what something happened where I extended a due date. So you have homework that's due today, and you're going to have homework that's going to be due tomorrow. So the homework that was due for today has extended right to tonight. I believe that's what I did. And then the homework that I'm assigning for today, that actually, it could be due for Friday. I'm going to change that. So I think I had it due for Wednesday, so I'm going to change that completely. So now the question is, what numbers am I going to assign? Because I think this is like some massive, like 42 question handout, and that's not going to be the case. So from here, you're going to do the following. So let's look. Why don't we do... Okay. Why don't we do the following? Yes. Let's do 1 through 10. Wait. We'll do 1 through 10. Let's do even. So 1 through 10 even. I'm writing this in the chat right now, so that should go to you. Hold on, what's happening? Oh, 1 through 10 even. Okay, and I'll put this also in the post. Let's also do. Let's do 20 to 30 odd, and then 42. I think that's fair. So why don't we try that? Any questions related to what we covered today? Any other questions? So again, I'll add these assigned questions to the actual assignment. So this way, if for whatever reason you don't have access to this later or you forget, you lost it, I will have that posted. I'll change the due date of the assignment so this way you have a little bit more time. And we'll see each other again on Friday. And that's it for today. Have a good one. Enjoy the rest of the week. I'll see you in a few days. And again, if you have any questions, just shoot me an email. Have a good one, everyone.